The first question on this test review says, which of the following represent a pair of opposite rays from the figure above? Now, when we take this test next class, it's going to be an online test, so we're not going to be able to highlight a bunch of stuff. But what you're going to get is a piece of paper that has 3 columns. One of the columns says keywords. So let's find the keyword here so we know what to write down on our show our work paper next class. What do you think the keyword is here in this problem? Or words? Opposite rays. Everybody circle it right now. The words opposite rays. If this were on the test, I would expect to see the word opposite rays written for this problem under keywords. Okay, now what does opposite rays mean? First of all, opposite outside of math context, what does opposite mean? Different things. And rays have a vertex and then a point and an arrow on one side. So we're just looking for things that go the opposite way. Are LA and LI, this first option, so LA and LI, are those opposite rays? Do they go opposite directions? Straight up opposite? No. They are rays and they do share a vertex, but they do not go the opposite directions. Okay, if we look at the next example, let's go B, LD and LV. So LD and LV, do those go opposite directions? No, they are rays. They don't go the same direction, but they definitely don't go opposite directions. Okay, what about option C? LA and LV. Those look pretty good to me. They're going opposite directions and they're both rays. So I'm going to hang on to that. A good student always goes through all the answer choices first. Option D is LI and LV. Do those blue ones go opposite directions? No. So we know confidently that answer choice C is the answer. So again, this is going to be an online test, which means as we go, you will be able to strike through answer choices. We pick C. We move on. Okay, the next question is going to use this diagram. Number 2 says, give another name for that. I don't want to say it out loud so we can see if we know what that is. That's going to be our key word. What is that? How would you say that? Line, and then the letters, right? Line, WF. We knew it was a line because what? It keeps going, yeah. If we see above the letters WF, there is straight up a line, which is line WF. So first things first, let's find on our picture here, line WF. Okay, here's W and here's F. So we're talking about this line that kind of cuts through the plane. What's another name for that? What else could we call it? Not line S. Remember when, so, okay, maybe. Line S and what? SF would work. Why would SF work? They're on the same line, and those are coordinate points. There is another way we could name this, though, and it's with the smaller letter. Do we remember how to use that? We would just say line A. Lowercase letters are just single letters for lines instead of using multiple letters for lines. So those are 2 options for another name for line WF. On the keywords portion of the test, you would write down line WF. That's your keyword for this problem. Next one says, name 3 points that are collinear. What's my keywords here? Collinear. Ooh, what does that mean? What does linear mean? Line. What does collinear mean? Lines that go together. So we are trying to find points that are on the same line. Okay. Name 3 points that are collinear. We've already highlighted this line right here. That's blue. Line WF. Are there 3 points that are on that line? What are the names of those 3 points? Points W, S, and F. Those 3 points, not A is not a point. Those 3 points are on the same line. If I asked you to do the same thing maybe for this green line, what 3 coordinate points could you tell me for the green line? NWP. So for the green one, we could say points NP. W and P. So there's two options there for how we could answer that question as long as we know what collinear means. Knowing our keywords is huge, especially for this test because we have learned a ton of vocabulary. Number 4, which point is not coplanar to points W and A? What's my keyword? Coplanar. All right, if collinear meant on the same plane, what does coplanar mean? We still have the word co, which means together, but instead of linear, what does it say? Like on a plane, planar. So together on a plane. So let's look at this plane that we have. It's the parallelogram. We just need to see which point is not coplanar to W and A. So what point is not on the same plane as W and A? F. Very good. See how F is like chilling off screen? F is not coplanar. So we're going to say point F is not coplanar to W and A because it's not on that parallelogram. Last but not least for this problem, it says give 2 other names for plane O. There's not really like a keyword here. We do need to know how to name a plane. So we're going to write a note to ourselves. To name a plane with 3 non-collinear points, which is a lot of words. So let me discuss what that means. If collinear meant on the same line, what does non-collinear mean? If you put non at the beginning of something. Not. So it is not on the same line. So we just need to pick 3 coordinate points on the plane that are not on the same line. We've already highlighted the 2 lines on here. So which 3 dots do you want to talk about that are just not all on the blue or not all on the green? Okay, we need 3 though. So let's say points D, A, and what else? P, sure. That one works because D, A, and P do not make a straight line, so they are non-collinear. We can name the plane that way. We cannot use W, S, and F because they're on a line. We cannot use N, W, and P because they're on a line. But any other combination of 3 letters, as long as they don't make a line, you're good. Problem 6. It says find the length of segment GH. What is my key word here? Segment is good, but length. Just because I'm thinking about what is it asking me for. Length is going to be like a distance. This is technically using the segment addition postulate. But it's really simple. When we learned about the segment addition postulate, we said that if we have 2 segments that are essentially next to each other on the same line, like this one and this one, they have to add together to what? 35. Well, if the whole thing is 35 and the green part, which is segment HO, is 15, how much is segment GH? 20. That's what we're asking for. So pow, there we go. We have our answer. It's B. Because 20 plus 15 equals 35. That is all that the segment addition postulate means for me. Small plus small equals big. It works for segments. It works for angles. Small plus small equals big. For question 7, you're going to do part of this one on your own, but I'm going to do part of it with you. It says the points M, A, R, and I are plotted below. Look, I plotted them for you. Sometimes that's the stuff that gets to be the hardest. Determine if segment MA and segment RI are congruent. Okay, give me some keywords out of this problem. Congruent. Love that one. What does congruent mean? The same. What did you say? Total. I'm looking for a word that starts with L, the same length. They are the same length. Okay, so we need to know the length of these 2 segments. I'm going to go ahead and highlight the 2 different segments for us because those are some good keywords right here. We'll have segment MA, which is this guy right here, and we'll have segment RI, which is this guy right here. For either of those 2 angles, to find the length on this coordinate plane, can I just simply count? No, why not? Because it's slanted. Yeah. So we can't just straight up count. Darn. We have to do something else. What should we do to find the length of a segment that's tilted? Maybe something that's on your formula chart. The distance formula. Very good. Everybody grab a formula chart. We're going to write down the distance formula on our review here so we have it. It is equation number what? 17. So we're going to write that down. The distance formula is D equal to giant square root x2 minus x1 close parentheses squared plus y2 minus y1 close parentheses squared. We want to write that down and fill that in every time we do this. I know a lot of us, because I watched our quiz being taken the other day, just go straight to our calculator with this problem. A lot of times students make mistakes in silly little things like missing a negative if they don't have it straight up written down on their paper. So I'm going to require that you show your work on these problems. That's why I'm going to give you a piece of paper to show your work on. The work for MA would look like the following. Okay, I'm going to scoot to the side. If we have point M is at the coordinate point 1, 4. Point A is at the coordinate point 5, 1. I am going to physically label those points. x1, y1, x2, y2. I do that because now I know exactly what to plug in for my formula, and I'm going to write that down on my paper. I'm going to ask that you do the same. So when I fill in this formula, we would have distance equal to giant square root. What did I label x2? 5. What did I label x1? 1. Close parentheses squared plus. See how I'm just filling it in? We've done this before. You've all shown me we could do this. We might have just forgotten for a second. That's okay. Oh dear. Drop the keys. Okay. What did we label y2? 1. And what did we label y1? Close parentheses squared. Okay, now it's a calculator time. At this point, we should know how to do this. I'm not going to say out loud how to do it. I'm just going to come around. If you need help, ask a person next to you or ask me. Yeah, what do we get after we put that in the calculator? 5. Awesome. Okay, that's the length of MA. That's the red length. Your job is to do the blue one. Whoa, that's not blue. What color did I use? Green. I want you to do the green segment from R to I. I want you to do exactly like we did the red one, which means you rewrite down the points from a computer screen, pretend it's on a computer, to your paper. You label them. You use the distance formula. We move on. Ready, set, go. We got this. I'm going to start working it quietly, which means if you're lost, you can look up here, but if you're still working, don't look yet. All right, so we've plugged it all in. When we press go on our calculator, it round to the nearest tenth, we should get 6.4. So all this work, remember, we're doing this problem to decide if the two segments are congruent. And we said earlier that congruent means the same length. This should be really easy to answer. Are these the same length? No. So we say no, the segment MA is not congruent. That's what that symbol means, so not congruent to segment RI. The equal sign with the little squiggly on top means congruent, so if you put a slash through it, it means not congruent. So this is answer choice B. We lost our little line over here, but there we go. Questions about that one before we move on?
Also, for some of you, if you got something different than 6.4, you have to make sure that you put it as a -3 in there. Some of you put -3 because I was walking around and I think you got like 5 something or a different number.
It's a good point. If you're plugging in a negative number, you might have a minus a negative, and that's okay. I know minus negative is positive, but minus negative is fine in the calculator. Okay, next question. It says the endpoints of DS, segment DS, are -3, 0, and 7, -8. Find the coordinates of the midpoint M. What is my key word here? Midpoint, very good. All right, everybody look at their formula chart. On the formula chart, there is a formula for midpoint. Let's write that down. What formula number is it on your chart? 16. All right, let's just write that down for ourselves. So we say midpoint is equal to x1 plus x2 divided by 2, comma, y1 plus y2, oops, can't reach, divide by 2, close parentheses. Now, we did do this last time on a little Post-it note, and we got a little bit better. So I don't want to go that much more over this one. We've identified the question, and we've identified the formula to use. I want to leave you to see if you can do it, because we all did it on that Post-it note last time. The one thing I want to remind you is you cannot type that whole thing in your calculator at once. We have to do this in 2 parts. You will do what I'm highlighting in red first in the calculator. Then you will do what I'm highlighting blue in the calculator, but not all at the same time. You have to do 2 separate parts here and then put them together in a coordinate pair. I'm going to stop talking. I'm going to let you think. Okay, now that you've had some time to think, here's what I would have done as a student. I would say, okay, I need to fill out a formula that has x's and y's, multiple things. I need to label stuff. Labeling is so important. So you take D and S and you write them down, and I would label it x1, y1, and x2, y2. That color scheme does not make sense. Let me try a different one. x1, y1, and then x2, y2. Okay, in the midpoint formula, I would be plugging in -3 plus 7 divided by 2, comma, 0 plus -8 divided by 2, close parentheses. Now remember, you can't do the red and the blue at the same time. I love that you listen to me so well that I keep saying, put what you write down on the paper in the calculator. You're right. Except for this one instance, you have to do it piece by piece, the x's, then the y's. But when you put this in the calculator, what coordinate point do you get out? What did you get?
Trey, what'd you get?
Huh?
What did you get as your answer?
On a D?
2, -4. Very good. D is correct. So again, 2 separate problems to get those numbers, but you put them together as a coordinate point because the midpoint is a place on a coordinate grid. So we need a x and a y. Okay. There are going to be 2 keywords in this next problem you would write down for me. Number 9 says, point M is the midpoint of AO. Find the length of AM. 2 vocabulary words. Midpoint and length. Fabulous. All right. We know that M is in the middle. It tells us it's the midpoint. What do we know about things in the middle? Let me rephrase. That's a weird way to ask that question. What do we know about these little tick marks? What do those mean? They're the same. They're congruent. Very good. The midpoint cuts things in half, which means the AM side should be exactly equal to the MO side. Okay. Which means if I have AM, I should be able to make it exactly equal to MO. So let's write that down. We have AM exactly equal to MO. Well, what is AM worth? What is its length based on the way the picture is drawn when he comes back? What's the length of AM? It's not a number. 3x plus 5. Okay, what is MO? Great, look what we have just made. That's a whole equation. We need to solve it. We've gotten really good at the box method, and I know that this is not a ton of space for you. I'm going to have to zoom in a little farther so I can actually get it all on there. But let's draw our line down the center of this. Let's draw our boxes, and let's do the box method. Okay. I'm going to walk you through the questions you should ask yourself for the box method. Once we have it set up, we say to ourselves, how many terms up there have an X attached to them? 2. So I put 2 boxes on the left side. How many terms do not have an X on them? 2. I put 2 on the other side. Okay. Now we drag and drop. And oh my gosh, please draw your arrows. When we draw our arrows, it's going to remind me to put things where they belong and change my sign. 3x, pow, goes right there. The 5 goes across the center line, so what do I write down? Fabulous. Cross the line, change the sign. The 2x is also going to cross the center line, so what do I write down? Negative 2x. And then the 7 crosses nothing, so 7. What do we do with all of those terms in the top? Add them. 3 plus negative 2 is a positive 1. Negative 5 plus 7 is a positive 2. If you don't trust me, you ask a calculator. Well, there we go. We've solved for x. Normally, we have to divide by the number in front of x, which I'll just do for consistency's sake. But when we divide by 1, literally nothing changes. So we got 2. Huzzah! Answer choice A. No. Oh, thank you. Somebody stop me. Why is that wrong? Yeah, remember, the question didn't ask for x. The question asked for the length. Oh, we are going to put the value of x as an answer choice. Make sure you're answering the correct question. It asks me for the length of AM, which is the blue part. If we know AM is equal to 3 times x plus 5, what did we just find out was x? 2. So really the answer here should be 3 times 2 plus 5. 3 times 2 is 6. 6 plus 5 is 11. Look at that. There's the answer choice we actually want. And look how tricky that was. Most likely, we are going to have the answer for x as an answer choice. Don't pick it unless it straight up asks you for x, which I don't think that it does. Maybe once. So answer the correct question is basically what I'm trying to get at. So now it's your turn. This next question will be worked the exact same, but it's going to give you a different vocabulary word. What's the vocabulary keyword here? Segment bisector. A segment bisector, bisect means cut in half, so it's essentially like telling you the midpoint. Since this midpoint, oh, that's part of the question. I'm going to say it anyways. Since this segment bisector is a point, it is essentially your midpoint, which means, again, we have these tick marks that show up. And what do those tick marks mean? Congruent. This is exactly like the problem we just did, which means this problem is going to be for you. I want you to answer the question here because it eventually asks you to find the length of EM, even though it doesn't say EM. If it says find EM, it wants the length. I want you to do both parts of this problem. You got it? Let's roll. We got this. Okay, I'm going to start working it for those of you who are finished, except that I put my pen somewhere. Now I don't know where it is. Of course, it's on my desk. Okay. I always leave it places. I don't know why I don't just put it down. Okay. So again, because of the word segment bisector, we know it cuts it in half. Bisect means half, so it acts kind of like a midpoint. So we know that this section, E to M, and this section, M to O, are going to be the same length, which means E to M is exactly equal to M to O, which also means 12x plus 7, the length of EM, and 9x plus 16, the length of MO, should be equal to each other. So pow, I just solved my little equation here. I'm going to use the box method again. This one's very small. There are 2 terms with x's and 2 terms without. We draw our arrows. Oh my gosh, please draw your arrows. That's going to be the number one reason students are going to miss this question. It's just silly little mistakes like that. We add, that would make 3x on the left side. We add, that would make 9 on the right side. We divide by 3, so x is equal to 3. And look how tempting that is. Make sure you know what the question is because we didn't ask for x, it says EM. Well, EM is the blue part, so I'm just trying to figure out what happens when I take 3 and I plug it in for x. Right there. 12 times, bless you, 12 times 3 is 36. 36 plus 7 is 43. So we should have gotten answer choice C. How did you do? I went through that really fast, but we had time to think about it. Okay, we need to take a quick pause because we've been doing a lot of practice problems. So we're going to do a quick little Blue-Kit. It is not the same Blue-Kit. It's a different one. Okay, for this next problem, now that we've taken a break, it says find the perimeter of triangle ABC with vertices -2, 3, 3, -3, and negative 2 comma negative 3 round to the nearest tenths. Okay, here's what I've done for you. I have already plotted those 3 points. We just need to connect the dots here on the grid. Negative 2 comma 3 means that A is up here. 3 comma negative 3 means B is down here. And negative 2 comma negative 3 means C is right here. So when we connect the dots, we would have the line from A to B. We would have the line from B to C. And we have the line from C to A. 2 of those 3 are going to be really easy to find the length of. Because when we look for perimeter, which is our keyword, I guess I should have started there. Perimeter just means add up all the sides. So we just need to know the lengths of each of those sides. Okay, when we find the length of all the sides, let's do the easy ones first. What's the length of the green part from C to A? That one should be easy. We don't even need a calculator for it. What is the length from C to A? It should be 6. Now, how do we know it's 6? We just count. Now, here's something that I've noticed about students as you do this. Watch my finger. This is the way you should count. 1, 2, 3, 4, 5, 6. Here's what I see from a lot of students. 1, 2, 3, 4, 5, 6, 7. What was the difference? I counted from the point. I don't want you to count the number of corners. I want you to count the number of boxes, which means you have to jump. 1 is where you start counting. 2, 3, 4, 5, 6. Seems silly to have to say that, but I've honestly seen it a lot where we needed to address it, which means if we actually count the jumps, how far is it from B to C? Oh, from B to C, the blue. 5. Okay, fabulous. So we already know that those 2 sides are 6 and 5. We need to know the red side. The red side is not something we can count because the red side is tilted. But we know that the red side has the coordinate points of negative 2 comma 3, that's A, and 3 comma negative 3, that's B. If I was showing my work from an online test, here's what I would do for the following. I would write down those coordinate points and I would label them x1, y1, x2, y2. Because what formula, again, am I going to have to use to find the length of that side? Distance formula. Now, we've written it on the paper before this. It is still on your formula chart, so let's fill it in to show our work. Again, because these are notes, we want to make them really good to study. Let's just straight up write down the distance formula first so we have it. This would be x2 minus x1 close parentheses squared plus y2 minus y1 close parentheses squared. I want to see that on everybody's paper because it will allow us to fill it in easier if we're looking directly at the formula. Okay. Now we have the formula. Then we have our labeled points. We just got to fill it in. For that red side, we would have x2. What did we label as x2? 3 minus x1. What did we label as x1? Negative 2. Close parentheses squared plus open parentheses. y2. What did we label as y2? Negative 3. What did we label as y1? 3. Boom. We're going to round to the nearest tenth when necessary. So at this point, turn to your calculator. Ask your calculator, hey, can you do this for me? You're going to type it in exactly as you see on your paper using the square root, the squares, the parentheses, the whole shebang. The minus and negative, all of that. I'll give you a second. All right, when we type that in our calculator, what do we get rounding to the nearest tenth? 7.8, Ms. Quigley. You're right, 7.8. All right, so now we have all 3 lengths. What do we do to find perimeter with those lengths? Add them up. So in your calculator, do 5 plus 6 plus 7.8. And when we do that, we should get our perimeter answer. 18.8. Fabulous. So the correct answer here is C. So if you need to write a note to yourself, since this is something you study with, perimeter means add all sides. That way, if you keep forgetting what perimeter is, because I've been asked by multiple students, what is perimeter again? It is adding all the sides. That's your key word. In number 12, what is the key word? Area. It's an area of a triangle, which means we need a formula from our formula chart. On your formula chart, can you tell me what the formula for area of a triangle is? Ooh, not just base times height. I think it's equation like number 2. Not just base times height. What's right in front of the b and the h? 1/2. So it's 1/2 base times height. Okay, so we're going to find the area. Boom, there's my keyword. This is what we should write down in the keyword section. And it says these vertices. Well, guess what? It's actually the same picture from number 11. So we already should know the base and the height of that triangle ABC. What's the base of the triangle ABC in my picture? 5. What's the height of the triangle in my picture? 6. So we right now should be able to figure out the area. What is 1/2 times 5 times 6? If you don't like typing fractions, what's the way you can use a decimal for 1/2? 0.5. So you could do 0.5 times 5 times 6. What is 1/2 times 5 times 6? Say again? I didn't hear you. 15. Very good. Now notice it is 15 units squared. We especially need to make sure that we're answering with the correct units here for area. So if you need to write a note to yourself, area means look for a formula, because the area for a triangle is not the same as the area for a parallelogram or a rectangle, which are the only 3 shapes we've really done so far. Okay, 13 will do with me, 14 will be yours. It says in the diagram, the measure of an angle BDA equal to 144 degrees. Find the measure of BDC. Okay. There's not really keywords here, but there are key angles. What's the actual question here? What am I looking for as my final answer? BDC. The little M in front of that angle thing says measure. So we wanted to measure in angles for BDC. Take your pencil or your highlighter right now. Let's make sure we know which angle is BDC. When we're looking for BDC, we're looking for this angle right there. BDC. The other piece of information we have is that the angle BDA is how much? $144. Okay. Here's what my brain did. My brain says, oh, look, that red angle, which is what I want to answer, is kind of like part of the purple angle. And if I add another angle here, this green one, doesn't that make up the whole purple one? So we have something called the angle addition postulate, which is just like segment addition. If there's 2 small angles that make a big one, they have to add up to the big angle. So if this green angle is 76, if the big angle is 144 degrees, what do I do to figure out the red angle? Very good. We're just going to do 144 minus 76 to get our answer. And what is 144 minus 76? 68. So we answer D, 68 degrees. That is the idea of the angle addition postulate, meaning little angle plus little angle equals big angle. Okay, I'm going to give you a challenge question. Number 14 uses the same idea, but a little bit different. I'm not going to say too much about 14 because you're going to do it, but what is the angle we're looking for? Ooh, I'm so glad you said that. Hold on to that thought. What is the angle we're looking for, though? Take your highlighter or your pencil right now, and I want you to highlight CDA. That's the one we're looking for. Okay? Now, Kate already said the next hint I was going to give you. It doesn't tell me any more information, but it's kind of like the problem we just did, because this purple angle is going to be worth how much? do we know it's worth 90? It's a right angle. Very good. This little box right here tells me it's a right angle. I want to kind of leave you here and see what you do with this information after thinking for a little bit. I want you to find the measure of angle CDA. You will have to set up and solve an equation and plug something in, but I want to see what your brain does. I see some of us are stuck, so I'm going to give you a hint, and or if you think you're doing it, just double check yourself. Here's what I would have done. And I'm going to stop right here. So if you needed a quick check on that, that's where I'm going to stop. Keep thinking. Thank you for working. If I was doing this one, I would notice that there are 2 terms with an x and 3 terms without an x. So we drag and drop the pieces where they belong. The term 3 at negative 3x goes here. It's fine. Oop, cross the line, change the sign. That's fine. Oop, cross the line, change the sign. And that's fine. We add across the top, we would get negative 5x. We add across the top, you would get 15. Now you divide by whatever number is in front of x, including the sign. So I am going to divide by negative 5 on both sides. So x would be negative 3, which feels weird because you're like, ooh, distance can't be negative, so testy. You're right, kind of weird. But if we plug it in the formula, because remember, that's not the answer. We want to know what angle CDA is. And angle CDA has a measure of negative 2 times something plus 55. And we just figured out what that something is. We figured out that it was negative 3. Okay, and I'm trusting my math here. Negative 2 times negative 3 is 6. 6 plus 55 is 61 degrees. So we should have answered A. How many of us got close? Okay. Now, it's kind of a preview for what your homework assignment is. We're going to basically get through this whole review. Your homework is to go back and redo 3 problems that we did on the very, very back of this. If you struggled with this question, maybe this is one of the ones you go back and redo. We've already done it once. I just want you to redo the problem again. So you're going to pick 3. If this one was a struggle, this is a good one to have as one of your 3 that you redo. Okay? On to the next page. The next question says, BDA is a straight angle. Find the measurement of angle CDA. I'm also going to have you try this one on your own. But we're going to highlight some key words here. What is a straight angle? 180 degrees. Really good that we know that. What angle am I actually looking for here? CDA. So I want this angle CDA. We also have an angle BDC. And we have an angle BDA. I want to see what you can do to put together a formula, solve it for x, and then answer my question. So I'm backing off a little bit more. I want you to do it. It's very much like the one we just did, but they're not going to add up to 90. They're going to add up to 180 because it's a straight angle. So even less. I want you to try from the very beginning. You got this. Okay, again, I see a lot of us setting it up really great and you're working. I'm going to start working it slowly for those of you who are finishing / maybe stuck. But I'm not going to say anything while I do it. Yes. So for this problem, we should have gotten D. So let's look through my work compared to your work and see if we need to ask any questions. We'll just take a quick second to look through it. If you needed to finish copying it down, that's fine. If I cut you off before you're done thinking, I apologize. Next problem we'll do together. It says, in the diagram, ray RT bisects angle SRQ and measure of angle QRT is 37 degrees. Find the measurement of angle SRQ. Wow, a lot of things happening. Give me some key words out of this one. Bisects. What does that mean? Two sides are congruent. Amazing. Let's write that down. We're going to write down two sides or two angles are congruent. That's a harder word, and we keep messing that one up. So we need to make sure that we know bisects means cuts it in half, gives it a midpoint, gives two congruent sides or angles. The other things that it tells me is that angle QRT is 37 degrees. It wants to know angle SRQ. Okay. We just said that an angle bisector is going to cut it into two congruent parts. So, like, don't think too hard about this. If this angle is 37 degrees, what's this angle? 37. Okay, 37 degrees. Amazing. That's what an angle bisector does. It cuts it into two equal pieces, which we know that means both of these are 37. So if I wanted to know the whole angle, well,
Add 37.
yeah, we would just add 37. What's 37 plus 37?
74.
Very good. So we know that the big angle is 74 degrees. Fabulous. We know that again because of the word bisector. It means that they are equal. Bisector means the two sides are equal. Bisector means the two sides are equal. Bisector means the two angles are equal. So knowing that that's what bisects mean, you're going to handle number 17 for us, bless you. It says in the diagram, ray DC bisects angle BDA. Okay, again, we see the bisects. We know that means that they are congruent. If we know that they are congruent, we know that they are equal. The question here asks me to find angle BDC. I'll help you set it up, but you're going to finish it. For this problem, what should I do with 7x minus 19 and 9x minus 37? Should I add them? Should I make them equal to each other? Equal to each other because of the word bisects. Very good. So we're going to do the following. We're going to say, and I'm going to put more geometry on it because I can't help myself. Angle BDC is congruent or equal to the measure of CDA. But we know both of those things. I'm going to leave you here. You plug in the algebra, you find me x, you plug it into the right angle, you give me, not the right angle as in like the 90-degree angle, but the correct angle that it's asking for, and then we move on. Again, I'm going to start working it slowly just for time's sake. Okay, I know I went faster than some of you guys can write, but were we on the right track, even if I cut you off? Okay, fabulous. The last three questions should be pretty easy because we're not really going to have to solve anything. And I know solving we're getting a lot better. Once we switch to the box method, I feel like a lot of us are doing really, really well. That makes me really happy. But the last problems are going to be more like just checking your geometry concepts. In number 18, it says angle 1 is a complement of angle 2. What's my key word there? Complement. What did complement mean? 90 degrees. Oh my gosh, write that down. Okay. We know that they have to be adding up to 90 degrees. If angle 1 is 63 degrees, what is angle 2? Exactly. What is 90 minus 63? That's exactly what this question is asking. And like, what is 90 minus 63? 27 degrees. Fabulous. That's all it's checking. Do you know the definition of complement, which means 90 degrees? The next one says angle 3 is a supplement of angle 4. What's my key word? What do those have to add up to? 180. If angle 3 is 43 degrees, what's angle 4? $137, and we found that just by doing 180 minus 43, 137. Amazing. Okay, complement, supplement. Put those words in your brain. That's what we need to know. Complement is 90, supplement is 180. Last but not least, number 20 says find the measure of angle 1 and angle 2. Let's start with angle 1. If we want angle 1, what does that equal to? 113. Why? What are those angles called when they're up and down like that? Starts with a V. Vertical angles. We're just trying to see if you remember that vertical angles are congruent. Oops. And if that's the case, what's angle 2? 67 degrees. Guys, it's just the same as its vertical angle, the one across from it. Can we handle that one? Okay, now I mentioned this earlier, but on the very back of this, you see how that last page is blank? I need you to choose 3 problems that you did not get the first time we did them. Just 3 on the whole review from questions 7 through 20. Let's avoid the first vocabulary ones because they don't have any work. From 7 through 20, I want you to pick 3 of them. If you come back with 3 problems redone on the back of this sheet, I will probably toss some extra credit points on your test because that's proving to me that you are studying for my class. Only 3. That's all I need you to do. So you pick 3 that were hard for you, 3 that you did not get the first time, and you're going to redo the problem on the back here. Just 3 of them. You bring that to me next time. We turn it in before we take our test. You probably will get some extra credit points. How does that sound? Great.